In this video, we're going to look at factoring trinomials with a leading coefficient of 1. So both of those vocabulary words that are kind of big words are important to this. We're talking specifically about trinomials, which are polynomials with 3 terms. And we're specifically going to look at ones where the highest power is x squared in this video. And with a leading coefficient of 1. So that means when there isn't some number in front of this x squared, so we can assume it's 1. And that's just to narrow down what the video is about and chunk things a little smaller, because it is possible to factor trinomials with leading coefficients other than 1. And it is possible to factor things that aren't trinomials. But this is the specific piece we're working on in this video. So in the previous video, we talked about factoring by grouping, and that we could use a strategy of, if we had a polynomial with 4 chunks, factoring something out of the first 2 chunks, and then factoring something else out of the second 2 chunks. And that's the same strategy we're going to use here. We're just going to have to break up this middle term into 2 chunks first so we can do it. So I can break up 8x a whole bunch of different ways. I could have 7x plus x. That would equal 8x. I could have 6x plus 2x, and that would equal 8x. 5x plus 3x, and that would equal 8x. I could even do weird stuff. I could do like 9x minus x, and that would equal 8x. Or 10x minus 2x, and that would equal 8x. And so there are an infinite number of these kinds of ways that I could break up 8x into 2 things. So I need a way to narrow that down, because I can't guess and check an infinite list. That would take infinite time. So to narrow down my list, I'm going to look for which one will factor nicely with my constant term, because it's going to have to factor nicely with this. Well, the x is going to do that part. And then I'm going to need the constant to factor nicely with this. So I need to pick a way to split this up that will factor nicely with 15. And so that means that I want to pick ones that will multiply to 15 and add to 8. Because if I have a way to break this up, it has to add to 8, or else I can't rewrite the 8 as it. But if it multiplies to 15, then it'll factor nicely with my 15. So I start thinking about ways to make 15 multiplying. I could do 15 times 1. That would certainly make 15. But when I add those, I would get 15 plus 1. I would get 16. So that one did not work. Well, what else can I do? I could do 5 times 3. And if I add 5 and 3, I get 8. So that tells me 5 and 3, that's a good way to break up this 8x, because I could factor that 3 or that 5 with that 15. And so I can get somewhere in my factoring. So I'll go ahead and do that. I'll take x squared plus 8x plus 15, and I will break it up, that 8x becoming 5x plus 3x. And if I added those together, I would get 8x plus 15. But instead of combining my like terms, I'm going to factor by grouping. Here's my first group. I can factor an x out of both of those. I get x times x plus 5 times x. And then I can go over here and I can I guess I can finish off this little bit before I do that bit. So then I can take those x's here, and I'm left with x plus 5 for my first group. My second group, I can't factor an x out because that doesn't have an x, but I can factor a 3 out of each term. 3 times x plus 3 times 5. So that means that I would have plus 3 and then I would have my x plus 5 again. And then I can pull out my x plus 5 because it's multiplied by both terms and get x plus 5, x plus 3. So the step was now I have to generate 4 terms out of my 3 terms by splitting the middle term. So let's look at a few more examples of that, and I'll teach you some more pieces of strategy to know how to split that up. X squared plus x minus 12. So this is another one where I need to split my middle term. But now I've just got an x here. I don't have a number. And I have a minus sign here. So that tells me 2 things. That tells me that this is going to be a 1 because it's 1x. So that means I'm going to need things that multiply to negative 12 and add to make 1 so that I can split up my x. And before I just start guessing things that might make negative 12, I'm going to think a little bit about multiplication patterns. And this is something that we haven't really talked about recently, but you have seen before in school, which is that if you have 2 positive numbers and you multiply them together, you get a positive number. And if you have a positive number and a negative number, you get a negative number, and it does not matter if it is the first or second number, it'll still be negative. But that if both of them are negative, you will get a positive number again. And that's the pattern for multiplication. For addition, if they're both positive, you're going to get a positive number. If they're both negative, you're going to get a negative number. And if the signs are different, it'll depend on which number is bigger. If different, then bigger number, then sign of bigger number. So, for example, if I have 4 plus a negative 3, I would have 1. And if I have negative 4 plus 3, then I would have negative 1. So I can tell right away that in this case, because I'm trying to add to a positive 1, that I want the bigger of the 2 numbers in my factor to be positive and the smaller of the 2 numbers in my factor to be negative. Because either of those will give me a negative here, and only one of those will give me a positive here. So I start thinking about factors of 12, and maybe some of you have already figured out which set of factors of 12, but I'm going to kind of go slowly and methodically. Once you see which one it is, you do not have to try them all in order. But it's okay if you need to try them all in order because you haven't yet mastered how to see what it is. So I might go 12 times negative 1. Well, that would be 12 plus a negative 1 would be 11. 6 times negative 2. 6 plus a negative 2 would be 4. 4 times negative 3. 4 plus a negative 3 would be 1, and that would be the way to split this one up. Because I have a 1 to split up, and if I rewrite it as 4 minus 3, then I'll be able to factor with that negative 12 in a way that will be useful in this problem. So, go ahead and do that. X squared plus 4x minus 3x, which would equal x. So I have the same value here, I've just rewritten it. And then I can factor by grouping. Both of those have an x. And after I've factored that x out, I get x plus 4 there. So hopefully that's what I get here too. Let's find out. I'll be able to factor a negative 3 out of each of these. So I'm going to do plus negative 3 x negative 3 times 4 negative 3 there, and I once again get a positive 4 there, so then I can factor that out of both parts because it's the same in each part. And get x plus 4 and x minus 3 as my factors. Now, let's look at another one. X squared minus 3x minus 10. So this time I have negative numbers both places. So I need two numbers that when I multiply them together, I get a negative, and when I add them, I get a negative. So I know that one of them is going to be positive and one of them is going to be negative, or else I would not get a negative when I multiply them together. And I know that the bigger one's going to be negative, or I wouldn't get a negative when I add them together. So that lets me start my guess and checklist. I need things that multiply to negative 10 and add to negative 3. So this time I'm going to choose them with the bigger one being negative. Well, negative 10 times 1, but negative 10 plus 1 would be negative 9. So that didn't work. Negative 5 times 2, negative 5 plus 2 equals negative 3. That one works. So that's what I want to break up my negative 3x as. X squared minus 5x plus 2x minus 10. I'm going to start skipping some of these steps that I've been showing. It's up to you when you start skipping those steps, but I feel like I've given you a lot of examples. So I feel like now it's okay to show you kind of how maybe someone would do this once they're comfortable with it. So I'm just going to announce, well, I can factor an x out of this first pair without showing that step where I did that. I'm just going to say x minus 5. But I think you can figure out where that x came from because I've shown you lots of examples before, particularly if you watched the other videos. And here, similarly, I can factor out a 2 and get plus 2 x minus 5. And then each of those have an x minus 5. So I can get x minus 5 x plus 2. One more example in this video. That is x squared minus 12x plus 32. So I'm going to do the same thing where I need numbers that multiply to 32 and add to negative 12. And now I know this is positive, and a negative times a negative is a positive. So since it needs to add to a negative number and multiply to a positive, I'm going to try negative numbers. And in this example, I just start listing. If you can see right away where to start guessing, you can skip to the right guess. But if you don't see those patterns yet, it's okay just to be like, well, negative 32 times negative 1. Negative 32 plus negative 1 is negative 33. That wasn't it, so negative 16, negative 2, negative 16 plus negative 2 is negative 18. That's not it, but I'm getting warmer. There's all kinds of strategies you can start noticing as you do this that I'm not getting into in this video, because I think you'll find it more meaningful if you find them yourself. So since 32 is not divisible by 3, I skip right to 4. So negative 8 plus negative 4, and that is equal to negative 12, and tells me how to split this up. So I get x squared negative 8x negative 4x plus 32, and then I can factor by grouping. This group, all I can pull out is an x. This group, I can factor out a negative 4. The sign changed because this sign got factored out, because I factored out a negative 4, and negative 4 times negative 8 makes 32, just like 4 times 8 makes 32. Then I can factor the x minus 8 out of each term and get x minus 8 times x minus 4. So now you've seen each of the different things that can happen with positives and negatives in these situations where we're factoring trinomials with a leading coefficient of 1.